All right, these notes are on how to graph a piecewise function. So you guys have seen piecewise functions a little bit already because we did take absolute value functions and rewrite them as piecewise functions. But now we're going to start with the piecewise function and we're going to learn how to graph it all on its own. So first we were going to go ahead and write the definition of a piecewise function. And you can do that in that blank space up here on your notes. So a piecewise function is a function that is made up of pieces of other functions. Each function is graphed for a particular interval. All right, so the first function that we have here is a straight line, y equals mx plus b, and there's no number in the front, so that means there really must have been a 1 there. And that 1 is not written as a fraction, and so I can go ahead and write that as 1 over 1. And so I know that my y-intercept is 2, and my slope is up 1, right 1, up 1, right 1. So when you're graphing a piecewise function, it's very important that you do this with pencil because we're going to draw the whole graph, and then we're going to erase part of it, okay? So I'm going to start off with 2. I'm going to go up 1 over 1, up 1 over 1, up 1 over 1. And down 1 over 1, down 1 over 1, down 1 over 1. And then I'm going to go ahead and very lightly connect those points. All right. Now, the second part of the piecewise function tells us the domain for that specific piece. And so what I mean by domain is they're telling us what inputs are allowed for that piece of the function. So this says you are only using this if x is less than 1. So right here, this is where x equals 1, so I'm going to put a circle around that. Now, just like when we do, when we talk about shading and solid lines versus dotted lines, if you run into something like this where you cannot equal it, says less than 1, it doesn't say it can equal 1, then you draw a hole right there, and that hole should not be filled in. That's just an empty hole. And then it says that we're using this for anything where x is less than 1, and x is less than 1 on this side, the negative values. Now, if it's written like this, x is less than 1, and the direction that the arrow is pointing is the direction that you draw the line. So what we're going to do, it says draw it to the left. We're going to make it dark for everything that it says. All those values where x was less than 1, we make that dark. And then we go ahead and take the other side and we erase it because this was the part that was not inside of the domain that the piecewise function used for that. So there's one piece. Now we have another piece, and the other piece is a quadratic. And so I'm going to go ahead and show you guys how to do this without using a calculator. And it's possible that sometimes I'll let you guys use calculators to do these, but I want to make sure that you guys know how to do it if you don't have one. So this is a parabola, which means we're going to start with our points that we use for a parabola. So to make sure that you are getting the correct points, you might need to go back and look at your notes. Or you could take y equals x squared, that's the parent graph, and plug in -2 to +2. So those are the points we're going to start with. And each of those points has been shifted to the right one. So I have the point -1, 4. Again, I'm doing this lightly. 0, 1, 1, 0, 2, 1, and 3, 4. And so I'm going to go ahead and draw this parabola very lightly. all right? And it says that I'm supposed to keep the parabola starting where x equals 1, and it can actually equal 1. So here is the x value of 1, and I'm going to fill that in. And then it says anywhere that the x value is greater than that, and the arrow's pointing to the right, and these are where the x values are greater. So I'm going to go ahead and make this dark. And then I'm going to go back and I'm going to erase the other side. So that's what my piecewise function looks like. Now, all of these are called functions, piecewise functions, which means they should pass the vertical line test. So if you take your pencil and you trace it along this, your pencil should not touch 2 points at the same time. Now I stopped here because it appears that my pencil is touching 2 points, but it's really not because the one on the top is actually a hole. That's like a missing point in the graph, and then my pencil is touching a point down here. So that's actually okay. And then as I keep going, I can see my pencil only touched 1 point at a time. And so that means I did it right. There's our piecewise function. All right. Next, we have this piecewise function. We have y equals -3 for these values, y equals -x squared plus 4 for the other ones. So here, when it says y equals -3, that's actually a horizontal line. So y equals -3, that's a horizontal line at -3. And here it says that we're using that if the x value is between -5 and -1. So between -5 and -1. And it cannot equal -5, but it can equal -1. So that's going to stay as a whole. This one is going to be filled in. And it's everything in between there. So I'm going to go ahead and make that dark. And then everything else needs to get erased. Okay, next I'm going to go ahead and graph my parabola. So again, I'm using those same points. And this is not because we only ever use parabolas, it's just the example problems happened to be quadratics. So this one has been reflected over the x-axis. So I'm going to go ahead and take all my y coordinates and make them negative. And then the entire graph has been shifted up 4. So I'll go ahead and shift all of these up 4. And I can go ahead, I'm going to graph these again. I'm doing it kind of lightly so that I can do some erasing when I need to. And we could have some more points here. So if you want to find some more points, we could say the first point, like 3, 9. If I plug in 3, I would get 9. And so over here, I would reflect that. And then I go up 4. So 3, -5. And then these are symmetric. Okay, so that's a little bit better. I've got more showing now. All right, and it says that the part of the parabola that we're keeping is everything that's greater than -1. So I'm going to put an open circle on -1, and then everything greater than that, all the numbers that are positive, 0, all of that, we're going to the right. So I'm going to go ahead and trace this and make it dark. And then I go back and I erase the other side. All right, now if you were doing this using your calculator, then you could have gone ahead and done -x squared plus 4 and looked at your graph. And if you're even being clever enough, you could look at the graph and start with an x value of -1 and then just graph a few of those points. That would be fine. So when we are doing this in class, I'll ask you to do a couple by hand and then I'll let you do some in the calculator, using the calculator to kind of help you plot your points.